Good morning, guys. Anjani Kumar here, dealing instrumentation subject for final year electrical students. So till now, we completed what is a measuring system. Till now, we completed measuring system. So in that, what is the definition of measurement and different types of instrument? We completed successfully. After that, we start static characteristics of instrument. So what are the different types of static characteristics? There are two types of desirable and second one is undesirable. So desirable means sufficient. Undesirable means we don't want these type of characteristics in every instrument. So what are the desirable static characteristics? Those are accuracy, resolution, precision, right? Linearity, sensitivity, reproducibility, repeatability, and range span, right? Static error. So these are desirable characteristics. We discussed each and every characteristics with neat examples also, right? And undesirable characteristics, those are hysteresis, right? After that, what are undesirable characteristics? Right? Hysteresis and what you call dead zone, dead time, threshold, right? After that, drift. In the drift, what are the different types of drift? Zonal drift, right? Zero drift, right? Span drift, and all these things we discussed successfully, right? So if you have any doubts, I'm ready to clarify your doubts. So definitely I would like to tell you students, definitely you should follow my videos. There is no doubt about that. You should clearly understand each and every concept of this instrumentation subject. And recently, from yesterday onwards, I'm uploading my videos to the YouTube. If you have any video clarifications or sound disturbances, you won't get these type of problems in further, because I'm uploading these videos into the YouTube. So better go to that YouTube and you should follow my videos, right? You don't have any other things, right? Definitely you should follow, right? Now we'll discuss about error analysis. It's very important concept. What is error analysis? So what is meant by error? Right? Each and every instrument that it has some error. You won't expect a 0% error instrument. Right? It depends on climatic condition, user readings. Definitely you should have some error. So it is very important for everyone. In order to deal the instrumentation, you should study error analysis. So what are the different types of errors? So there are two types of errors. Those are static error, and the second one is a dynamic error. Right? So what is meant by static error? The error that can be present at a static condition, means time invariant condition. Time invariant condition. The error, what is meant by dynamic error? The error at time variant condition. So at dynamic condition. So these type of errors are called dynamic errors. So we have a syllabus only static errors. Briefly, we should explain, right, each and every error with example, with solved examples also, right? So first, what is error? So error we can also call static error, right? So we can also call absolute error, right? A static error or we can call it as absolute error. It can be denoted by epsilon naught or delta A. So it can be denoted by epsilon naught or delta A. So what is meant by error? So error is equal to, so what is a measured value? Difference between measured value and true value, we can call it as an error. Right? So what is AM? AM is nothing but, in order to find the quantity. So what is a is means unknown quantity. So you are finding that quantity. So measured value, AM is called measured value. AT is called true value. So the difference between measured value and true value, we can call it as an error. Very, very important. Right? So what is meant by error? Error is nothing but the difference between measured value and the true value, we can call it as an error. Right? If you have delta R, delta V, delta I, means these are errors. Errors when finding the quantity of R, resistance, find the quantity of voltage, finding the quantity of current. So the error can be absolute, error can be denoted by delta. So these error may be plus or minus. Right? These errors may be plus or minus. But suppose if AM greater than AT, so what is error? Delta A is equal to AM minus AT. If AM greater than AT, this is called positive error. Right? You can apply negative quantity to reduce the error. Right? If AM greater than AT, we can call it as a positive error. So in order to reduce that error, you should apply negative quantity. Right? If AM less than AT, so that is called negative error. That is called negative error. You should apply positive quantity to reduce error. Right? Error may be plus or minus. Right? So how you can denote the error concept? Delta A is equal to plus or minus AM minus AT. So this is the absolute error of absolute error. Right? So what is meant by absolute error? So we can call it as a static error or absolute error. So it can be denoted by epsilon naught and delta A or delta A. So what is meant by error? Error is nothing but difference between measured value and true value, we can call it as an error. So AM is called measured value, AT is called true value. Right? So if you want to know anything, if you want to know the error of a resistance, it can be denoted by delta R. If you want to find the error from the voltage, delta V, like delta I. So error should be plus or minus, either plus positive error or else a negative error. Right? If AM greater than AT, that we can call it as a positive error. We need to apply a negative quantity to reduce that error, to make that error zero, whatever it may be. Right? If AM less than AT, that we can call it as a negative error. You need to apply a positive quantity to reduce that error. So actually error should be defined as plus or minus AM minus AT. So this is called absolute error. Right? So you clearly understand what is absolute error. Alright? Next we'll move on to the second concept. What is a percentage error? Right? So what is a percentage error? We'll discuss about percentage error. So what is a percentage error? Right? So it can be denoted by percentage epsilon. Alright? So what is a percentage error? So what is meant by percentage voltage regulation means V no load minus V full load by V full load into 100. The same thing, percentage error means AM minus AT by AT into 100. Percentage means into 100 plus or minus. So we can call it as a percentage error. So what is meant by percentage error? AM minus ET by AT into 100 we can call it as a percentage error. So how you can denote it? What is AM minus AT? You know the delta A is equal to plus or minus AM minus AT na. So what it is? Absolute error na. Absolute error na. So it can be denoted by delta A. Alright? AT into 100 na. So what is percentage error? Percentage error is equal to absolute error by true value into 100. So this is very, very important. So till now we covered about what is an error, what is a percentage error, right? So if you won't define, if you won't use a percentage into 100, if you won't use into 100, then that error we can call it as a, if I'm not using percentage, so what is meant by AM minus AT by AT, I'm not using 100 percentage, so then that error we can call it as a fractional error, right? With that, if you apply into 100, then we can call it as a percentage error. So what is meant by fractional error? Right? So percentage error is equal to, so that can be denoted by percentage epsilon, that is equal to delta A by AT into 100. So that is nothing but AM minus AT by AT into 100. Right? What is a fractional error? So for that percentage error, you are not using your percentage. So what is a fractional error? So this can be denoted by a epsilon. So this can be denoted by epsilon. So what it means? AM minus AT by AT. So in problems, you will know epsilon, then find out the measured value. So for this we have a problem. So epsilon is equal to, we have a formula like epsilon equal to AM minus AT by AT. So from this, AM minus AT is equal to epsilon AT now. So AM is equal to epsilon into, so if we common AT, so epsilon plus 1. If you know the fractional error, it is easy to find out the measured value. So this is the one type of formula. So till now what we covered, what is an error? Error can be denoted by epsilon naught. So what is error? The difference between measured value and the true value, we can call it as an error. Right? After that, what is a percentage error? What is a percentage error? AM minus AT by AT into 100, we can call it as a percentage error. It can be denoted by percentage epsilon. Right? If you won't use a percentage, then we can call it as a fractional error. So it can be denoted by epsilon. So what is a fractional error? AM minus AT by AT only. So what is epsilon? Epsilon is equal to AM minus AT. If epsilon given, then find out the measured value. You know the true value, then how you can find out the measured value? So AM is equal to AT into E plus 1. So this is a formula. Right? Right? You know the percentages. So what is the percentage error? AM minus AT plus or minus by AT into 100. See, if this percentage error is done by user itself,